Thank you for tuning in today. My name is Nathan Pattenham, and today we're going to be doing something a little similar to what we were doing 2 days ago, where we implemented the stack class, which I have the code for right here. So I was reading some of the comments, and even though the stack class demonstrates the stack features that we talked about, there's a lot of things that I'm not really addressing here because we're using the Python programming language in terms of memory management and in terms of error handling. Because in the case here, when we talk about peek and pop, we assume that the size is always going to be greater than 1. What happens when our user tries to peek and pop from a stack where there's nothing in it? And these are the questions that we're going to try to answer in this video. So we're going to re-implement the stack class using a list, an array, and there's going to be a couple more features that we're going to add to it, so that way I can address memory management as well as error handling. So let's get started. So first thing I'm going to do is show you some of the unit tests I created. It's going to be a little bit different from the unit tests I created last time. So we have some unit tests to check to make sure that we can create our stack. And then we have this thing called get capacity. So beforehand, when we were talking about the stack in our implementation here, we didn't really worry about setting a certain number of items our stack could hold from the very beginning. But in this case, we will, since we're using an array, we can allow the user to establish a capacity and say that at the very beginning, I want a stack that can hold 10 items or 3 items or 4 items and so on and so forth. And so basically, we're going to say that by default, our stack will auto set its capacity to 10. And then we're going to try setting the capacity and seeing what happens. We're going to try adding an item. And then we're going to try removing an item when there's nothing in our stack. And this is where we're going to have to deal with some error handling. Then we're going to try to peek into an empty stack. Like I said, again, we're going to have to deal with error handling in this case scenario. Then we're going to try to remove an item from our stack. We're going to try to get the size, and then we're going to see what happens when we add, when we specify a capacity, but we add one more thing to it, and we have to, in our code, extend the array that we're using since we fixed it from the very beginning. So now let's get started with the code. So the first thing I'm going to do is run my unit test to show you that out of all 9 of them, they're all failing in some sort of way, whether it's through an error for a method that hasn't been created yet, or whether it's because it's actually failing. So let's go to our stack class, and let's get started. So we have the same methods that we had last time, except get capacity, and I'll get to it when I get to it. So the first thing we want to do in our constructor is let the user specify capacity. And the nice thing about Python is we can assign optional parameters, which means that if the user doesn't pass in a number, so in this case, like right here, then we can have it automatically assign a value, which in our case will be 10. So we'll say capacity equals 10. And so in implementation, we're going to be using a array. And so in Python, the way that we can predefine an array of certain sizes by saying take some brackets to denote a list, type in the word none because it has no value, and then we're going to multiply it by our capacity so we can create an array of the size of our capacity where everything is blank and we're able to add items freely to it. Another variable we'll have is size to keep track of the size. When we create a stack and there's nothing in it, the size will be 0. And then we'll have a variable to keep track of the capacity, which we'll call capacity. Now, a couple things we can do is we can finish the methods for the size and the capacity that will return it back to our user. So the size of method, which will just be return self.size, and the get capacity method, which will just return self.capacity. So let's see if any of our unit tests are passing. And we had one passing unit test, and so that would be, if we look at this right here, F means that the unit tests are failing, and dots mean that they're passing. So the third unit test is passing. So if we go back to our unit test, we can see that get capacity is working. This one right here. So we just finished in the get capacity method. So now let's go to peek. So the first thing we should do is talk about what happens if a user tries to remove or tries to peek at a stack where there's nothing really in it. And so what we're going to do is we're going to throw a runtime error, and then we're going to put in a message to alert the user when they see our error from trying to peek into an empty list what's happening. So we'll say if our list is empty and we have a method that's called isEmpty that will just finish right after this, then we'll do raise runtime error. Otherwise, we'll just return what's at the front of the list. So we'll do self, or what's at the very end of the list. So we'll do self.items, and then we'll return whatever is currently going to be at the top of our stack, which will be whatever's to the right in our list from implementation. And so in our case, self.size. So for example, if we had one item in our stack, our size would be 1. And so in this case, since Python uses zero-based indexing, we have to subtract from 1. So let's see if our peek method works. Let's go to, well, it's not going to work because, well, we can first look at the test to see, to make sure that's throwing that error if we're trying to pop from a empty stack. So we'll go to test remove item from. It'll say runtime error is not raised. So we'll go back to our code and see if self.dot is empty. And we didn't finish this empty method, which is why that unit test is not passing. So this function is empty will return true if the list is empty, and will return false otherwise. So we can say something like return self.size equals 0. So now we're passing the 2 unit tests that I discussed, that talk about peek. So what happens when we try to pop from an empty list? So it'll be the same idea. So self.dot is empty. Then we will raise a runtime error. And one thing I forgot to do is specify. So you can specify a message in Python that will display to the user what's happening. We'll say pop method called on empty stack. And here we can say, peek method, pop method called on empty stack. So what we're going to do is we're going to decrement the size by 1. So self.size minus equals 1. And then we'll return the thing that's on top of the stack. So we'll return self.items, self.size, because we've already subtracted 1 here. So we don't have to subtract from 1 again like we did in peek. So now we have, before we had 6 unit tests failing, now we have 5. So now we'll do the push method. So the first thing we want to do is, so now we have a capacity. And so that limits the amount of items that can be put onto the stack. So the first thing we should do is check to see if the stack is full or not. So we'll do if self.dot is full. And then we'll say that we should extend self.dot extend. So there's a couple things I'm doing here, and I'll get to it first. So first, these are just methods that I haven't defined yet, which I'll define right underneath it. And the reason why I'm using double underscores in front of the name is because these are methods that I don't want people to be calling my stack. These are basically like private functions if you've used Java before or written code in Java. And so the way that we denote that in Python is by putting 2 underscores in front of the method name. So we can say something like define is full. And here we'll just return if the size of the array right now is equal to the capacity. And then we'll have another one called extend. And this one might be a little bit more logic, and I'll go into it and talk about it a little bit in depth. So the first thing we want to do when we extend it, so the idea of extend is we're going to double the size of our list, and we're going to add all the, we're going to create a new list that's double the size, and then we're going to add items from the old list to the new list. So the idea is we're going to do new array is equal to none, times, and in parentheses we'll take the self.capacity and we'll multiply it by 2 so we can extend it. And then we'll do for I comma item and enumerate of self.item. So what we're doing, so what enumerate does is it will get the index, which will store an I. So the first time this goes through, I will be 0, then 1. It will go up to the length of the list minus 1, and then the item will be the actual value. So if my list had the numbers 3, 5, 6 in them, item the first time will be the number 3, then the number 5, then the number 6. And enumeration is a cool feature that we can use in Python to be able to do this. We'll say new array underscore I is equivalent to item. And then at the very end, what we can do is we can delete what is currently being used to store all of the old values. And then we can say self.items equals new array. And then what we can do is say self.capacity is going to be equal to double itself. And let's see, extend. Oops. And then now that we finished the two helper methods, we'll say what we want to do is, so say for example the size is 1, or say for example you have one item in our stack, our size be 1, then we can just, since we have zero-based indexing, we can just do self.item of the current size is equivalent to the item, and then we will just increment the size. So now we only have one failing unit test, so we'll do set capacity. So right now the unit test is saying when we set the capacity to 3, we're getting back 10. So now if we go back to our unit test and we see that's failing, we see that we have 3 where it says we should get the capacity back and it should be 3. And the reason for that is that I put our stack right here, which is referencing to the one that we made at the very beginning, which would be 10. When in reality, I should have been representing small stack. So now our unit tests are passing. So now let's see. So we talked about memory management and how we're using that with our extend method, which will be extending it every time we reach our capacity, and we'll just be creating a new array twice the size and restoring the values in it. And so with this implementation, we're going to be having the same time complexity still with pop and push and peek, and is empty, and those operations are all going to be in constant time order 1. And so with this implementation, we used a list. We could have very well used a linked list with nodes, and we would still get in the same time complexity. But the reason why I used an array is it was a little bit easier to implement. I can implement it with a linked list if you want me to. Just comment down below. But yeah, thanks again for watching, and tune in next time when we talk about DEX.